Every one of you have learned about this limit definition in school, where you take the derivative of fx and it equals to the limit of h approaching 0 of fx plus h minus fx over h. What does this formula even mean? How does it come about? So before I begin, I must first explain you where it comes about, right? So let's say I give you a graph, and this is the graph of y equal to x, right? So every value, when you plug in, say 1, you get 1, right? Obviously, that's how it works. So now if I were to ask you how to find the gradient of this line, I think every one of you have learned that to find the gradient of a line, you must do y2 minus y1 over x2 minus x1. So let's say I want to find the gradient. I draw a triangle. I have these two coordinates, right? Let's say this, then what we do is, this one is x2, y2, this one is x1, x2. So we do y2 minus y, oh sorry, this one is y1, y2 minus y1 over x2 minus x1. So basically a tiny change in the x-axis, a tiny change in the x-axis, and a tiny change in y-axis. So what is a change in y over change in x? This is what the gradient function does. So now let's say I want to find a gradient of a curve. Now this one looks like fx equal to x squared, right? So now let's say I want to find a gradient of this dot. What is the rate of change at this point? What does it mean? So let's say I want to find a rate of change at this point. I need a tangent line, right? This tangent line that passes through this dot only once. And the gradient of the tangent line is a gradient at this point, right? But how do we even derive a tangent line? Because there are multiple tangent lines. There's one tangent line here, there's one tangent line here. There's so many tangent lines, and you can't possibly calculate the total number of tangent lines. And you should know that when you're given a curve of fx equal to x squared, the gradient changes every value of x. So how do we find it? So what we do is we find two adjacent points. We want to find this gradient, right? So what we do is we draw a secant line. This is known as a secant line. Okay, so what does this secant line do? So what we do is first we plot the points. What is the coordinate of each of these points? So we plot them down. Now I'm going to assume this is h. The difference between the two x coordinates is h. So this is x. This is x. This one is x plus h. This one is fx. This one is fx plus h. Right? So what are the two coordinates? The two coordinates is x, fx, and this one is x plus h, fx plus h. Right? So now using this very formula we just learned earlier, using this formula, we can plug in here, right? What do we get? F x plus h minus f x y2 minus y1 over x plus h minus x, which is what? Fx plus h minus fx over h, right? So this is the gradient of the secant line. This is the gradient of the secant line. But this does not find the gradient of a tangent line at one point, right? So how do we find it? What we do is we let this h approach 0. So these 2 points become infinitely closer to each other, such that this secant line becomes a tangent line at this point. So then we use limits. We let the limit of h approach 0 of fx plus h minus fx over h. This is how the limit definition of the derivative of fx with respect to x. So the change in the y-axis, the change in fx over the change in x, is the limit of h approaching 0 of fx plus h minus fx over h. I hope you understand this video. Thank you.